Hello, GAC. This is Coach Johnson in my classroom today. I know today you're really excited about preparing for your test Friday, Monday, and hoping that everything that we're going to talk about here is going to be beneficial for you. Unfortunately, today this podcast is not live, although it does indicate that it is. It actually is not because I have a game today, so I apologize for that. Also, a couple notes. Tomorrow's test is going to be different than Monday's test. Tomorrow's test we actually have and mostly it's over like the triangle stuff, filling in the correct triangles. We also have with law of cosines, law of sines, make sure the vector equations, how to apply those and use them. Knowing a vector if it's trying to get in the same direction, how to identify that and go after that there. So all of those things, make sure we're good on. And again, make sure if you need any other extra help, come in tomorrow morning, also Monday morning, because Monday I know is over all the word problems and whatnot. I think there's 4 total on Monday, and on Friday there's about 10 or 11 total. Make sure also if you're going to come in tomorrow morning, make sure that time when you come in is around 7:40, 7:45, because I will have duty within that time frame before. All right, let's get started. Let's get it underway. All right, let's pull up this. I'm going to pull up the screen share thing. We're going to start on numbers 2 and 3 and then progress forward. The important thing to note with numbers 2 and 3 that I think is important to talk about is on 2 and 3, there are different things that you're going to need to know how to use when talking about specific triangles. For instance, in the one that we're looking at number 2, some of you might need to draw it out, where angle A in this example would be 41 degrees. Angle B would end up being 72 degrees. Angle C we don't know. And we know that little c, little b, and little a are all 3 different values that we can apply. So in this one, A is 15, and then we can kind of keep going forward off of that. So in this example, since it's side or angle, angle, side, we know angle, angle, side, and side, side, angle, and we could keep going down the list. We could go angle, side, angle, are all dealing with sines, whereas side, 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 and side angle side are dealing with cosines. So again, let's look at 4, so we have it here. With 4, actually let's look at 3. I think I just did 2. This is number 2. This will be number 3. 3 we have 17, which is little a. We have B, which is 39, and C, which would be 50. So what I would like to do is find what the big angle A is, big angle B is, and big angle C is. And in doing that, what I'm trying to do is try to solve for that specific angle. So if I had 17 squared equals 39 squared plus 50 squared minus 39, actually it's 2 times 39, times 50 times cosine of big A. Now the problem with doing this right here is that when I do this right now, you're solving for your smallest side, and you know the problem with that is when we're doing this, we always want to solve for the biggest side first. It's just kind of a thing that we like to do in the way we approach it. So instead of doing 17 for the cosines, we're going to do 50 instead. So let's put 50 squared equals 17 squared plus 39 squared. Let me make sure I put the smallest side. Let's do the largest side. So let's do angle C. So we have minus 2 times 17 times 39, all times cosine of big C. So when I do this, what I want to do is 17 squared plus 39 squared. Okay, I end up getting 1810. I'm going to subtract 1810 from both sides. So here we go. Subtract 1810, 1810. So when I do that, I end up getting negative 1,308. And then I'm going to end up dividing by whatever I get over here. So 2 times 17 times 39. And again, that's negative, just so you know. So we have, when I divide by that, I get 1308. Divided by 1326 is what I have right now to get 0.9864, yada, yada, yada. Well, then before we actually write that down, we're actually going to take the cosine inverse of that. And when we do that, when I take the cosine inverse of that value, I end up getting, let's make sure we're Make sure you're in degree mode too, y'all. Make sure you're in degree mode, because what happens sometimes, and as I did, if you don't do that, then what happens, it becomes difficult for you to solve there. So let's make sure we are in degree mode here. It's actually, I said 502, it should be 50 squared. There we go, it's a lot better. 1810. And so really I have a negative or positive 690 divided by, yeah, here we go. And that's why it's important to make sure that you plug in your values correctly. And when I do that, I get negative, let's see, negative 0.52036. That's a lot better. So when I end up plugging in my answer will then indicate that it is 121.36 degrees as angle C. So after I get angle C, what I can do is now plug this back into the law of sines. When I plug it back into the law of sines, I can then find out what the other angles are for angle B and angle A. All right? Now let's look at the law of sines up here. Law of sines indicates that when we find sine of 41, we can put it over the opposite side over here. So sine of 41 over 15 equals the sine of 72 over little b. So when I cross multiply, I get 15 sine of 72 equals b sine of 41. So I'm going to divide by sine of 41, divide by sine of 41. And when I do that, I end up getting 15 sine of 72 divided by sine of 41. Let's delete that there. We'll divide this by sine of 41. And my answer should be 21.74. And again, we'll keep it to 2 decimal places. And again, that would be for side B. And again, I could solve for this other angle by doing the 180 subtracted from it, and then solve for the third side by doing the law of sines one more time. Okay, so the important thing to note is when we use law of sines and cosines, and then solving for that third and final side. Look at number 5 too. It says determine whether the given information results in one triangle. So when I kind of move forward off of that, the important thing that we want to find out is how many triangles do I have? Well, if B is 12 and C is 15 and big C is 55 degrees, let's use the law of sines to be able to solve for it. So let's do sine of 55 all over 15 equals the sine of big B all over the little b, which is 12. So when I cross multiply, I get 12 sine of 55, enter, divided by 15, and then I take the inverse sine of that, which when I do that, I'll end up getting big B is equal to 40.94. Okay, 40.94. So as I look at this, again, I'm going to assume that this also has another angle B. So this is first angle B. We're going to assume that it has another one. So we remember that the one that I solved for, I subtract from 180. So I subtract from 180 along with the other angle, which was 55 there. So when I do that, I get 84.06. I'm sorry, hold up, backtrack, I'm sorry. For this one, it's only 180 minus 40.94. So when I do that, I get 139.06. Remember that these two angles have to add up to be equal to 180. So this should help us get what angle A is, angle A, by now saying, all right, 40.94 plus 55 subtracted from 180 gets me what? So 40.94 plus 55 subtracted from 180 would get me an answer of 84.06. So I'm going to write 84.06 down below. Now I look at the next one, 139.06 plus 55. And I notice that when I do 55 plus 139.06 to try to get my other angle A, it is over 180. So because of that, we do not have this angle. Therefore, we do not have another triangle. So therefore, we only have one solution. Again, remember, if we would have no solutions, it would hit us back with an error on that as well. All right, so again, that was number 5. Let's look at number 6. Number 6 says find the component form and magnitude of the vector with an initial point of -4, -1, and a terminal point of -2, -5. Again, to find the vector here, we do x2 minus x1, and then I put an I with it. And then I do y2 minus y1 with a j with it. So when I put these together, I'll do -2, which is my terminal or my second equation. And then this one over here is my first. So -2 minus -4. When I add these two together, I'll get 2i. And then when I do the y's now, I have -5 minus -1 to get -4. And I'll put a j with it. So 2 minus 4j would be my vector. And to find my magnitude, remember, I'll do 2 squared and then obviously plus -4 squared. So I'll have 4 plus 16. The square root of that would be the square root of 20. And then the square root of 20 would be 2 square roots of 5. All right, make sure you simplify that square root when going forward. All right, number 8, we can look at briefly, maybe even on Friday morning or whatnot before the test. Number 9 would be a good one here. It says find a unit vector in the direction of, and then it gives in the direction of v, and then v is 4i plus 2j. Now you'll notice that all the formulas are on your other sheet if you so need that. Okay, so again, if I want to find a vector that's in the same direction, we do v hat equals my vector a comma b all over my magnitude of v. So if I was plugging this in, what I would have for my component form would be 4 comma 2 with the greater than less than sign. Now to find what my magnitude is, I find 4 squared plus 2 squared, which would be 16 plus 4, which would be the square root of 20. And when I do that, I'll end up getting 4 over square root of 20, comma 2 over square root of 20. So in order to kind of find this out, I want to simplify this to where if I did the square root of 20, I would get 4 over 2 square roots of 5, comma 2 over 2 square roots of 5. Now divide these out, My answer is 2 over square roots of 5, comma 1 over square root of 5. So I multiply top and bottom by square root of 5 there. So my ultimate answer should be 2 square roots of 5 over 5, comma square root of 5 over 5. So this is a vector that is in the same direction as my original that I was given, the 4i plus 2j. Same direction, same everything. The only difference now is this has a unit or a magnitude of 1. So what if I said now I want, I think there's one here. Oh yeah, like number 11. Number 11, let's say I transported number 11 to number 9, to where I said then at the end that I want to adjust its length to be 10 units long. Well, if this is 1 unit, to adjust it to 10 units, you'd simply multiply by 10 on both of these. So it would be 20 square roots of 5 over 2, or over 5, comma, 10 square roots of 5 over 5. So this has same direction. Now this is 10 units long. And now if I were to divide these out, I would get 4 square roots of 5, comma, 2 square roots of 5 as my answer. So again, when discussing vectors, we want to be sure that if we're trying to find one in the same exact direction, we use our formula by the magnitude. All right, very good. Well, we're rolling right on through. We've done a little bit of everything today. We might be able to come back to number 8. Let's do number 10. Number 10 is a good one. That would be a good problem there. Let's look at number 10. All right, number 10 states that find a vector the same, or I'm sorry, not that, number 10. Find the angle between the two vectors. So I have 5, 4, and I have also -7, 8. And again, I think I did put this on your other sheet, and as I do, I notice that it's there, but just in case, I see that there is a little bit of a difference there. Let's put this down. So the dot product of UV let's go back. Cosine inverse, cosine of theta equals the dot product of UV all over the magnitude of U times the magnitude of V. So as I look at this one, the dot product on the top is 5 times -7, which would be -35, plus 4 times 8, which would be 32. So right now at the top, we have -5, 35 plus 32, which we get -3 on. And then on the bottom, to find the magnitude of U, we simply do 5 squared plus 4 squared, and we do the square root of it all. So we'll do the square root of 25 plus 16, which would be the square root of 41. Now let's do it for V. Same thing, square root, -7 squared is 49. plus 8 squared is 64, so it'd be 3, carry the 1, so it'd be the square root of 113. Now let's take one of those ones out. There you go. So now I'll have the negative 3 divided by the square root of 41 times 113. And then once I get to this point, now I'll do the cosine inverse of both. And when I do the cosine inverse of both, I'll end up getting, so I'll do cosine inverse of all this. Again, remember down here's square root of 41, square root of 113. And my answer should be 92.53 degrees, 92.53 degrees. And so again, that would be the angle that is measured between the two vectors. All right, nicely done. Let's go to the next one here. Man, there's a lot of good ones here I could pick and choose from. Man, there's a lot of good ones. For instance, number 14. We've already done kind of number 12 and 13. Let's look at number 14. Number 14 states angle B is 36 degrees, A is 3 yards, and C is 6 yards. All right. Now the formula is down below, and I'll go over this before the test because I know I didn't hit it very often. There might be one on the test maybe. But with this one, it's 1/2 the two sides that don't correspond to an angle. So we'll do 1/2 times 3 times 6 sine of 36. So again, this is A, this is C, and this is big B. Notice all three are different here. In order for this to work, that's got to be the case. So now, when I multiply this out, I should get 9 sine of 36. Good. And when I do that, I get 5.29. So what is my area of this triangle? You got it, 5.29 yards squared. Excellent, 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 excellent. All right, look at number 15. Number 15 is a good one too. I mean, all of these are good. This one states that vector W equals 6i plus 8j. And I also know that vector V equals negative 2i minus 4j. Now in this example, what they want me to do is find a couple things. What is vector W plus vector V? Well, in order to combine them together, we simply add the i's and the j's to where I get 4i plus 4j. Look at the next one, 2w minus v. Well, in this one, we multiply 2 times w to get 12i plus 16j. Then I subtract v. Well, if I subtract v, remember it also corresponds to each one that's in the parentheses. So I should have 12i plus 16j plus 2i plus 4j. So the i's combine together to get 14i plus 20j. And again, that would be my answer for when I combine them together. Look at the next one. So this is number 1 over here. All right, number 1. This is number 2. Let's look at number 3. Number 3 says, what's the dot product of W to V, of the two vectors, dot product of them? Well, now again, I multiply the first two together, 6 and negative 2 to get negative 12. And then I add 8 times negative 4, which would be negative 32. So completely, I would have negative 44 as my answer. Negative 44. Also, on the next one, number 4, what we're trying to do now is trying to find the magnitude of vector W and the magnitude of vector V. To do this, what we do is we simply take the square root of a squared plus b squared. And so when I do that, I get 36 plus 64, which if done right, should be the square root of 100. So right now I've got for my magnitude, put this magnitude here. Magnitude of W should be 10. And magnitude for V should be 4 plus 16, should be square root of 20. Again, this should be 2 square roots of 5, as we saw in a previous chapter there. Now, finding the angle between them, again, you do the same formula we did previously. So over here, what we'll do, we'll put this in yellow. And again, to find this angle, we do cosine of theta equals W, dot product of W and V, all over the magnitude of W and also the magnitude of V. So again, if I have WV as my dot product is negative 44. Negative 44 divided by 10 times, I'm sorry, let's do this. Let's go. Putting these magnitudes in. So right now we've got negative 44 on top, and on the bottom we'll have 10 times 2 square roots of 5, and then we'll also do cosine inverse in order to get this theta by itself. So we'll have negative 44 divided by 100 times 2 square roots of 5. All right, let's press enter here. Again, we're going to take the inverse of that. And when I did that, I got an answer of 169.70 as my answer. Okay, 169.70. So again, as I go down there, we're just using step by step to ultimately get from A all the way down to F. Also notice that component form, if I were to draw this in component form, which is really step number 1, it would be 6, 8, and then also negative 2, negative 4. All right, negative 2, negative 4. All righty, as we keep going, we have 2 more left to do. These are so good, so good, so good. And these deal with the forces, all right? So we have 2 forces here. Force number 1, we'll put in red, is at 80 pounds at 30 degrees. So here we go. We got 30 degrees here, and we're at 80 pounds. Again, that is my magnitude and my direction. The next one states that at 210 pounds, we are at 100 degrees. So if we go from here all the way around 100 degrees, I know that what is left over would end up being 80 degrees. So I have 80 degrees here. And I also know that this would end up being 210 pounds. 210 pounds at 80 degrees. So if I was trying to get these as far as A is concerned in terms of I and J, what I would do is I could just say the sine of 80 equals opposite, which we don't know, we'll say it's J, all over hypotenuse, which is 210. So multiply by 210 on both sides. 210 sine of 80. We get 206.81. 206.81 for my J. Notice it's going upwards, so it's going to be positive. On the other hand, you notice that the cosine one is dealing with the I, therefore it's 36.47. Because it's going to the left, we know that that's going to be our J. Or it's going to be negative I, negative with an I. Our next one would be 80 sine of 30 and 80 cosine of 30. So with the sine is up and down. Well, that's our J. Because that J is positive, we're going to go 40J, and our cosine would be 69.28, and it would be positive as well because it goes both up and to the right. Now, this is A. What we did right now is we have our 2 vectors that are situated here, but the resultant only comes when I combine these 2 together. Just like Ford, me, Tyler, when we picked up that we have a combined force, that's what we're doing here. 32.81 I, and the next one's 246.81 J. All right, excellent. So that is our vector. Right now, we have our vector. But now we've got to do 2 things. We've got to find what it is as far as its magnitude is concerned by doing Pythagorean theorem. And the next one is direction by doing inverse tangent. So if I do tan inverse of the J, or the opposite side, over the adjacent side, 32.81, I could find what my direction is. So let's do tan inverse of 246.81 divided by 32.81. All right, so when I do that, I end up getting 82.43 as my angle. All right, 82.43 as my angle. If you get something that's negative, it's okay. That just means that it might be in the negative direction, so you might have to adjust that a little bit. Or if I found that, you know, this when I solved for it that it was actually in quadrant 2, then you would take that angle and then subtract from 180 to get what the angle, and as far as this is concerned, the angle is in purple. Okay? Now let's do the magnitude. If you're at home, I know what you're saying, Coach. This is so riveting. Please give me more. I know. It really is. I love this stuff. I really do. Let's take the square root of this. I got square root of 61,991.67, And when I did that, I got 248.98. So when I took the square root of that, my magnitude was as follows, and I have my magnitude in my direction. All right, last but not least, let's look at our last one. Coming on down. Let's do it. I have 2 boats. Each boat leaves the port at the same time. The first boat sails 16 miles at a bearing of southeast, south 20 degrees east. So I go south 20 degrees east. All right, so right now I have 20 degrees here. I also know that right now we traveled 16 miles. So we've got that right there. Next one. It says the next one leaves the port and sails 12 miles on a bearing of south 60 degrees west. So south 60 degrees west. It's going to be a little bit bigger there. And it goes at 12 miles. All right, 12 miles. The question is how far away are they from boat to boat? So here's boat 1, here's boat 2. And because we pretty much know everything. You notice that we know that this is 80 degrees. We have a side and we have a side. So because we have side angle side, what are we going to use? You're right, law of cosines. We're going to use the law of cosines to solve for this opposite side. So we're going to say this, a squared equals 12 squared plus 16 squared minus 2 times 12 times 16 cosine of 80. So let's do this. Let's plug this bad boy in our calculator to see how far they really are away. Again, how far they are away is the side that's opposite from the angle. So 12 squared plus 16 squared minus 2 times 12 times 16 times cosine of 80. All right, let's take the square root of that. It should be 18.26 miles. So again, that would be what I would end up finding in order to solve for that triangle solve using the law of cosines. Again, I hope you were excited today. We are good to go. As I wrap it up, again, I hope you have a tremendous, tremendous day. I know that it's just going to be absolutely marvelous, absolutely marvelous. And yeah, hey, if you have any other questions, please make